Hi, Pri. Good morning.
Morning, sir.
Hi, Harish. Good morning. Let's start the class today, right now. Okay, let's begin the class. So before that, yeah, how was Diwali? What did you guys do? Hmm. The weekend that where you were free, right? Last weekend.
Yes, sir. We celebrated. Didn't do much.
Okay, guys celebrated. Okay. So you guys got your well-deserved break. Hmm.
Yes, sir.
Like use all the breaks you get properly, okay? To refresh, relax, rewind, talk to your friends, everything. Okay. Now what we need to do is like right now we have to get our focus back and start working on our prep, on our goals basically. All right. So last class we were doing limits. Let's continue with that. All right. So here's your first question on the screen. Hmm. Right. Start solving. Let's see what happens. Is this Shri Giridhar a part of the class? Shri Giridhar. There's one person named Shri Giridhar.
Not sure, sir.
Not sure. Okay. Came and left quickly. Start solving this. Start solving this anyway. Let it be. Hmm. 1 by x square minus 4 minus 1 by x square plus 3x minus 10. What happens here? Yeah, so this is nothing but 1 by x minus 2 into x plus 2 minus 1 by x plus 5 into x minus 2. I'll take x minus 2 common, right? So I'm trying to make a common denominator. So all of this will be included. That's right. Right. So then here on top, there'll be an x plus 5. Here there'll be a minus of x minus 2. So that becomes minus x plus 2. And this becomes limit x tends to 2. I always forget this part, okay? Guys, you guys make sure you don't forget that part. Now, you have limit x tends to 2. Yeah, here x plus 2 will be there. So this becomes minus. Then I get 3 by x minus 2, x plus 2, plus 5. Right. So when I put a value close to 2, what happens? This x plus 2 becomes 4, a value close to 4. X plus 5 becomes a value close to 7. And x minus 2 becomes a value greater than 0 or a value little less than 0. Right? Which makes sure this whole quantity is plus or minus infinity accordingly. Hmm. So what do you say about the limit?
Does not exist.
Exactly. Right? Limit does not exist. And let's move ahead. If any doubts, please ask. We just continue. Limit tends to infinity. This is more of a sequence and series related problem. I'm giving you a clue here. 1 by 2 into 3, 1 by 3 into 4, 1 by n into n plus, sorry, n minus 1. Not like it matters, but anyway, n minus 1. All right, what does this become? Find this limit. Guys, the rest of you, if you have any doubts, please ask. All right,
Okay.
look at this limit. You guys, what do you do with this problem? It does exist here. It does exist. It exists here. So come on, try. So in sequence and series, you would have learned that if you get such a series, that you get 1 divided by 1 into 2, I can write the numerator as 2 minus 1 divided by 1 into 2. This is the first term. If I take the second term, all right, 1 divided by 2 into 3, I can write that as 3 minus 2 by 2 into 3. Why am I doing all this? So the idea is if I get any 1 by n into n minus 1, I can write that as n minus n minus 1 divided by n into n minus 1. Are you all getting this much?
Yes, sir.
Okay. Then what does this come out to? Like you replace n by 2, you'll get the first term here. You replace n by 3, you get the second term here. Okay. All right. The first term, second term, and all you'll get. Now, what does this become? This basically becomes 1 by n minus 1 minus 1 by n. Right. Okay. So the same thing applies for each and every term when I substitute the value of n also. So I can say that limit n tends to infinity. If you're not understanding, please stop me and ask. All right. This 1 by 1 into 2 becomes 1 minus 1 by 2. I just put n equal to 2 here to get the first term. Now, I put n equal to 3. What happens? This becomes 1 by 2 minus 1 by 3. I put n equal to 4. This becomes plus 1 by 3 minus 1 by 4 and so on all the way up till 1 by n minus 1. minus 1 by n. Any doubts here, guys?
No, sir.
So what happens here? Now, if you have any doubts, please look and ask. You can even stop me and ask me to slow down. All right. Need not be a doubt as well. So 1 by 2, 1 by 3, 1 by 4, all the way up till, the previous term for this would be what? 1 by n minus 2 minus 1 by n minus 1. You can see in the next term, like take the second term here, the first part cancels out with the second part of the previous term. So like this, each term, the first part cancels out with the second part of the previous term. All right. Are you following? So all these terms simply cancel out, and what I'm left with nothing but limit n tends to infinity 1 minus 1 by n. You getting this?
Yes, sir.
All right. So then what does this become? 1 by infinity, 1 by n, which is 1 by a huge value, is close to 0. So I'm just left with 1 minus 0, which is nothing but 1 here. Do you understand this problem?
Yes, sir. Correct.
Yes, sir.
Did you enjoy this problem?
Yes, sir. After like that second step, it was I
Yes,
understood.
second step is the fun part actually. All right. The idea that you can make this product of two terms into a difference of two terms, and using that you can cancel terms out. All right. So please take note of that and be careful next time you solve a similar problem. Okay. You got this? Hmm. Okay, we'll do trigonometric limits. Now, what is limit x tends to 0 sin x by x?
1.
Okay. So how do we quickly derive this? Like quickly derive, not classical derivation, quickly derive. You can apply this rule. What is this rule? I taught this rule last class. I just gave a slight intro to this rule.
Differentiate numerator and denominator until it gets 0 by 0 form.
Correct, correct. So whenever you get 0 by 0 form, what you can do is, if it's a numerator by denominator form, differentiate the numerator and the denominator separately. What does the numerator become? Then it becomes cos x. The denominator becomes 1. You're differentiating with respect to x here. All right. Now, what is limit x tends to 0 cos x? Cos 0 is 1. That's it. Or you can use the expansion. Suppose you didn't know L'Hopital rule. You can say that sin x is nothing but x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial all the way up till infinite terms. Okay. This is the series of sign. If you didn't know this, please note this down. Cos x will be nothing but 1 minus x square by 2 factorial. Yeah, I forgot almost. Plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on all the way up till infinity. Okay. I just suggest you remember this because when you differentiate LHS and RHS, what will happen? You will get the condition for cos x. Okay. Are you getting this? To differentiate LHS, you will get sin x becomes cos x. To differentiate the RHS, x becomes 1. X cubed by 3 factorial becomes 3x square by 3 factorial. 3 and 3 factorial cancel out to give 2 factorial. Like that, it just keeps going on. All right. Okay, so this is the expansion of sin x. But we are looking for sin x by x. Okay, can be written as x minus x cubed by 3 factorial plus x power 5 by 5 factorial and x power 7 by 7 factorial and so on divided by x. All right. This becomes 1 minus x square by 3 factorial, x power 4 by 5 factorial, and x power 6 by 7 factorial, and so on. Don't forget, you're putting limit x tends to 0. I'm telling this to myself more than you. Right? So when you put limit x tends to 0, what happens? These remaining terms all become 0. And I'm left with the value 1 here. Got this?
Yes, sir.
Yes, sir.
Right. Very easy, right? So remember this, sin x by x is 1 here. Okay. Now, what about this limit x tends to 0? Tan x by x.
One, sir.
Remember, you can write this as exactly, it's 1 only. Tan x, you can write as sin x by cos x into x. All right. Now, cos x when limit x tends to 0 is nothing but 1. All right. You basically get limit x tends to 0 sin x by x, which you already know is. Okay. Got this. So, yeah, limit x tends to 0. Okay, what about this one? L'Hopital rule will easily give you the answer. Okay. Like here, tan x becomes 6 square x and x becomes 1. And what is 6 square 0? It's 1 by cos square 0. It's 1 only. All right. Even
One
this
by
also
two.
will give you the answer first. But I would urge you to try a method without using L'Hopital rule in case they ask you in your school exam. All right. Try understanding limits first before applying L'Hopital rule. So L'Hopital is like your final card. You're getting nothing. All right. You have no idea how to solve it, then just use L'Hopital and see where it goes. Right. It can be used to verify your answer also. If it's a subjective answer. Right. But yeah, what can you do?
1 by 2, sir.
No. So how do you solve it? How do you solve it?
I use L'Hopital.
Well, not to use L'Hopital. No? So without using L'Hopital, how can you solve it? Think. L'Hopital will directly give you the answer 1 by 2 quickly. Right. You have no worries. Minus cos x becomes sin x. X square becomes 2x. And then you get 1 by 2 into sin x by x. Limit x tends to 0. 1 by 2, you take it outside, you know limit x tends to 0, sin x by x is 1. You get 1 by 2 as the answer. That is fine. But here, how do you solve it without that? You see that you have a 0 by 0 form, right? That's the first thing you notice. 1 minus cos x, you take that as 2 square x by 2. Right? See this? And then you have x square here. I will write that as 4 into x by 2 the whole square. You see this? Then I get 1 by 2 from 2 by 4. Right? Limit x tends to 0. Sin x by 2 by x by 2 the whole square. Right? So when x tends to 0, I can also say that x by 2 tends to 0. Getting this?
Okay.
Then this becomes limit. Like I write x by 2 as t. There's nothing but t tends to 0. Sin t by t the whole square. So basically you get 1 by 2 into 1 square, which is nothing but 1 by 2. All right? Any doubts here, please ask. Don't be embarrassed, just ask.
So we can also multiply 1 plus cos x in the numerator and denominator, right?
What do we get there? Oh, yeah, absolutely. So you multiply 1 plus cos x. What you will get on top is 1 minus cos square x. Okay, once again, the rest of you who aren't listening, 1 plus cos x, you just multiply it in the numerator and denominator. That's the idea here. Okay. Now, 1 minus cos x into 1 plus cos x is 1 minus cos square x. Now that I will remove and write it as nothing but sin square x. 1 minus cos square x, nothing but sin square x. X square into 1 plus cos x. Now, sin square x into divided by x square. When I put limit x tends to 0, is nothing but 1. Okay, so this becomes 1 square. And this thing, 1 plus cos x becomes 2. Alright, so you get 1 square into 1 by 2. Same answer you get. Okay, nicely done. Alright. Now, square minus 4, divided by x square minus 4, when x tends to 2. What does this become?
Sir, is it 0?
0. How did you get 0, da? You
Sir, I
put-
multiplied x square minus 4
You multiply it
in
by
the numerator and denominator.
x square plus
X
4.
square minus 4.
You multiply it by x square minus 4 in numerator and denominator. Or x square plus 4.
It's x square plus 4.
4 plus 4. Then this becomes x raised to 4 minus 16 divided by x square plus 4 into sine of x square minus 4. The problem here is when I put x into 2, denominator becomes 0. But also at the same time, because of this part, sine of x square minus 4, numerator also becomes 0. It's still indeterminate form. Right? So that approach is not the most helpful approach here. All right? When you directly put x tends to 2 here, what happens? It already becomes 0 by 0. Right? You getting this?
But,
Huh?
sir, I didn't really understand.
So here, when I put x tends to 2, I get 0 by 0 form. Okay. What happens here? It becomes sine square. 4 minus 4, right, which is nothing but sine square 0, divided by x square minus 4, which is already 4 minus 4, which becomes 0. So you get 0 by 0 form, indeterminate. Okay. When I multiply by x square plus 4 on numerator and denominator, the thing is this becomes x square minus 16, the denominator. Okay. And there's nothing to cancel out with in the numerator other than this x square plus 4, which I just multiplied into it. All right. This sine square x square minus 4, nothing is cancelled out.
Okay, sir.
You following?
Yes, sir. Yeah.
Okay, so that is what happens here. One second, what is going on? Okay. So what I'll do is I'll simply replace x square minus 4 as t. It's an unnecessary step, but once I do this, you'll understand. Okay, how to you yourself will come up with the shortcut for this. So x square minus 4 is equal to t. So when x tends to 2, what happens to t? T tends to
0.
exactly. Just put x tending to 2 in this, and you get 4 minus 4. So you can see t is tending towards 0 here. So the limit changes to limit t tends to 0, n square t divided by t. Right? Sine square. Oh my god, I'm so sorry. I didn't notice this sine square here. I was thinking of it as sine. All right. I didn't see the sine square there. That's my bad. So this becomes limit t tends to 0 sine t into sine t by t. When t tends to 0, sine t by t becomes 1. Sine t becomes 0. So the entire limit actually becomes 0. I'm so sorry there. All right. You were actually right from the beginning itself. The answer was 0. Okay. Guys, any doubts here? Any clarifications required?
No, sir.
Right. I was thinking of it as sine
No.
x square minus 4 divided by x square minus 4. It was actually sine square. Yeah, my bad. Right. Got this, no?
Yes, sir.
Yes.
Now, let's look at this question here. X tends to 3 sine of x square minus 9 divided by x minus 3. What happens here? What does this limit come out to?
Sir, is it 6?
Yes. Absolutely. The value will be 6 here. Rest of you, are you getting the value 6 or are you having trouble? 1. Guys, the
I'm
trick here
not getting
is to bring the angle x square minus 9 into this, all right, into the denominator. And for that, you know you have to multiply with x plus 3. Since you multiply in the numerator, you multiply in the denominator. Since you multiply in the denominator, you multiply in the numerator as well. All right, x plus 3. Now what I get is sine of x square minus 9 divided by x square minus 9 into x plus 3. All right, limit x tends to 3. Do I need to reinforce the fact, or do you already know that this is equal to 1? This is coming to 0 by 0 form, sine of t by t, when t tends to 0. Okay, this whole thing becomes 1, and you're just left with limit x tends to 3, x plus 3, which becomes 3 plus 3, which is 6. Are you understanding how to form the shortcut here?
Yes, sir.
You see the sine of some angle, you try to bring that same angle below. That's the idea. Okay. Right. It's as simple as that. You try to bring the same angle below and then start solving. Okay. You're always on the lookout for a sine t by t when t tends to 0. Right. So, okay. Sine pi x by square minus 4. So I'm just checking if you guys understood the shortcut properly. This is much more confusing than the previous problems. So please try, but try anyway. Come on. You get the answer. Like Lapita rule will definitely land you the answer, okay? But that's not what I'm looking for. I'm looking for you to do it the classical method and try to find the value of the limit at x tending to 2. Guys, how would you do this? Can you please guess? Can you please guess? If you're not getting it, it's okay. Alright, the point is to learn here. Can you please guess what it could be?
Multiply by pi. Numerator and
Multiply by pi is an approach, yes. Numerator and denominator. But then this x square minus 4 is a pain, right? And the problem is, like, I won't multiply by pi here, okay, frankly. Right. Question. Oh, sine of pi x by x square minus 4. Limit x tends to. So the idea I need is the form, something I already know is sin t by t is equal to 1, right? So this angle should tend to 0 and the denominator should tend to 0 after it. So first thing I have to notice is that the angle should tend to 0. Okay. Are you following?
yes, sir.
All right. Oh, okay. Noted myself. So sine of pi x. So I want this quantity first to tend to 0. That's the idea. Okay. All right. So I know it's, if I put x tends to 2, it will become sine of 2 pi. That doesn't become angle 0. I know that sine of 2 pi is 0. That's good. But that's different. I want the angle to tend to 0. That's the approach here. Okay. So then what can I do here? I can write sine of pi x as sine of 2 pi plus x. Sorry, 2 pi plus pi x. Sine theta, sine of 2 pi plus theta. It's the same thing. Sine of 4 pi plus theta and so on. But then when I put x tends to 2, what's the problem? It does not become 0. Okay. So what I'll do is, instead of that, I will write this as, oh my God, the question keeps disappearing. Sine of pi x by x square minus 4. All right, limit. Okay, something wrong with the pen. So much practice, I'll become great at limits. All right. So we have sine of pi x by x square minus 4. So I will write sine of pi x. Like I can imagine the 2 pi there. All right. I put x tends to 2 there, it becomes 2 pi. I'll just remove 2 pi from it in the sense that I'll write it as 2 pi minus pi x. Right? Are you getting this? Then I can see the angle tending to 0. But then sine of 2 pi minus theta is nothing but minus of sine theta. So I put this minus outside to balance the whole thing. Okay, now my angle is tending to 0 when I put limit x tends to 2. Getting this, guys? Any doubts?
No, sir.
Okay, so then this becomes minus of sine pi into 2 minus x, right? So I can make the numerator eat the minus sign up. All right. So then it becomes limit x tends to 2 sine of pi into x minus 2 divided by x square minus 4, which I'll write as x minus 2 into x plus 2. And like Aditi said initially, I'll multiply and divide by pi. Why? Because I see this pi x minus 2 tending towards 0. So there should be a pi x minus 2 accordingly in the denominator. Okay. So this is what I try to do. All right. So you can see this blue part divided by blue part becomes nothing but 1 here when I put limit x tends to 2. What about the remaining part? The remaining is pi by x plus 2, which becomes pi by 4. Apply L'Hopital rule, you'll quickly get the answer. But these are steps I want you to be aware of for a proper understanding of trigonometry. Whatever I learn in trigonometry, I want you to apply it here. And then see bit by bit what is happening. Okay, getting this? All right, I hope all of you have got this. Okay. If you didn't, please ask. Like, try to figure it out. Take a minute, but yeah. So now that you saw the steps, try to do the steps on your own. I'll give you a minute. And actually do that problem. That's a pretty interesting problem. So do it nicely. So if this looks too complicated, there's a simpler substitution. What you can do is, when x tends to 2, you want a t that tends to 0. Okay, anyway, you're planning to bring this angle inside to 0. Right. So you need a t that tends to 0. We can start with that. So t should be what? X minus 2. Right? T is x minus 2 here. I'll bring that into this. So when x tends to 2, t becomes 0. And then sine of pi into x, which is pi into t plus 2. X is nothing but. So the denominator becomes x square minus 4, which I write it as x minus 2 into x plus 2. All right. So x minus 2 into x plus 2, and x is nothing but t plus 2. So x minus 2 into x plus 2. Okay. So I see that I am getting limit t tends to 0, sine of pi of t plus 2 pi divided by t into t plus 4. Now, sine 2 pi plus theta is nothing but sine theta. So I'll write that directly as sine pi into t. Now, I see this angle is pi t, and I know that the limit t is tending to 0. So the numerator here becomes with angle 0. All right. So what I just need to do is bring in pi. So then it becomes pi t. So you can see this cancels out to become 1. Sin pi t by pi t. Okay. And then I'm left with t plus 4, which is coming out to pi by 0 plus 4. Are you all getting this now?
Yes, sir.
Am I audible? Because I don't think you guys are audible to me.
No, sir, we can hear you.
Sir, yes, sir, we can hear.
Sorry. What did you say?
We can hear you, sir.
Okay. All right. Then let's do some more problems. Limit x tends to 0, x by sine inverse x. All right. What do we do here?
Multiply sin x in numerator. Multiply sin.
Multiply by sin x in the numerator and denominator. Okay. So you're saying this sin x by x becomes 1. That's your idea. That actually pretty interesting method. Yeah. Okay. Is that what you meant? Sin x by x? To bring in that sin x by x?
No, sir. You
Okay,
can't multiply only sin, sir.
Huh?
Only sin, sir.
Only sin. Let me check. By sin inverse x. You multiply by sin x in numerator and denominator, right? What did you mean by only sin? I didn't follow.
So no, sir. I think it's a wrong method, sir.
Okay. No. That's all right. It's all right. Not a big deal. Okay. So what I would do is, since I already know this, I'll say that x is equal to sine theta. Okay. So here I can directly say that sine inverse x will be nothing but the value theta, because at x tends to 0, you know this value theta will also tend to 0. That idea. Okay. I'm putting theta between minus pi by 2 and pi by 2, principal value range. Okay. So I can say sine inverse x will be theta, and then this becomes x is nothing but sine theta tends to 0. In other words, I'll put theta tends to 0. Because theta is between minus pi by 2 and plus pi by 2. Theta has to tend to 0 here. X is nothing but sine theta. And sine inverse x is nothing but theta. And this is nothing but 1. Are you following? Okay. So you see all this sine inverse x and all, don't get scared. Replace x by sine theta and start solving. Okay. Right. So what about limit x tends to 0? Sine inverse x by x. Over that, what happens to that?
One.
Okay. Similarly, all these are nothing but 1. All right. When x tends to 0. Okay. Just remember this. Not remember this. Understand this properly. Okay. Right. So all of you got this? Then what happens if you differentiate sine inverse x?
One by root over 1 minus x square.
1 by root 1.
Okay. Perfect. So you should understand that the slope of the graph sine inverse x will always be positive. Right, because it's root of 1 minus x square, root cannot give a negative value. It's one way of thinking about it, that's all. It won't be always be positive, it will be 0 here at x equal to 0. Because, sorry, at x equal to 1, is when it will become 0. 1 and minus 1. So you get something like this. That'll be the graph of sine inverse x. You know how to construct the graph of sine inverse x, right? Draw the graph of sine. Take between minus pi by 2 and pi by 2. And then draw the line here. And then just make it like this. Okay. That'll be sine inverse x graph. Now, anyway, let's move ahead. Okay, what about this? Sin x by sine inverse x. What happens here?
Sir, is this 1 as well?
Yeah. How you do that quickly is to divide the numerator by x and the denominator by x. This is 1 numerator. Denominator is also 1 here. Got this? Right. So you get the answer as 1 itself. Correct. Now, because sin inverse 3x divided by tan inverse 2x will be so you're looking to divide
3 by
by
2.
Sorry.
3 by 2.
Yeah, we'll find that out. Correct. I think it's correct. Sin inverse 3x. So you make this denominator 3x, you can see 0 by 0 happening. We bring a 3x here. Next, tan inverse 2x divided by 2x into 2x. So when you calculate, I want you to remember this and this part. The part I'm cancelling out in your mind. And just write 3x divided by 2x to get the value 3 by 2. All right? Got this? Okay. So I hope you got the shortcut now. No. Wait. Practice that here. Sin of 3x minus sin of x divided by tan inverse 5x. Okay, what happens here? So I'll just tell you the shortcut form. I want you to use how. Okay. Yeah, tell me.
2 by
What do you
5.
think, ma'am? 2 by 5. Absolutely. The shortcut form here is 3x minus x by 5. Actually, the shortcut form would be 3 minus 1 by 5, which will come out to 2 by 5. I hope you're understanding where and how I got this. Okay, I've done the detailed explanation of the shortcut right now, the previous problem. And I've applied the shortcut and shown you how I applied the shortcut. I hope you can make the connection on your.
Yes, sir.
You get what happened here?
Yes, sir.
If you're not getting it, please ask. All right. Okay, then try this. Limit extends to 0. Cos x minus cos 5x divided by x squared. What about this? What's cos c minus cos d? Okay, forget that. What is the answer here? Come on. Multiple ways of doing the problem. So please try anything you feel out. Except Lapita rule. But right now it's cheating. In an exam hall, it is not. Okay. So, yeah, come on.
So is it minus 12?
No, that minus sign is wrong. Other than that, it's right. Can you tell me how you got it?
Sir, I expanded the numerator and then
You expanded the
multiplied
numerator
and
now.
divided by 6.
You
Sir,
expanded the
using that
numerator.
formula. Minus 2 sine.
Huh? Sorry. I didn't hear you.
Minus 2 sine 3x into sine 2x.
Okay.
So can you hear me now?
Yeah. Yes. I can. So it's 2 sine, like cos c minus cos d is 2 sine, minus 2 c minus d by 2. Okay, which is x minus 5x by 2. All right. Sine c plus d by 2. Okay. So the thing is, that's where the minus sign went wrong. Are you getting this? All right. So you got 2 into sine x minus 5x by 2, which is minus 2x. So I like that as 2x because that minus comes out and cancels out with this minus sign outside. Into sine 3x divided by x square. I'll write that as x into x, and then I'll write that 3x into 2x. And then since I bought 3 and 2 from the air, I'll multiply it by 6 on top. So what I'm left with is 1 here and another 1 here, and 2 into 6 is 12. Got this? Got where the minus sign went wrong also? It's a tricky formula, that's
Yes,
why.
sir.
It's normal to make that mistake, it's okay. But now be aware, all right, from now. Okay, but well done, well done. So, okay, we'll move on to the next type of limits. Exponential and logarithmic. Limit x tends to 0, e power x minus 1 by x will be will this come out to what does this come out to, guys? It's 1. Okay. E power x can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus x cubed by 3 factorial and so on till infinity. Okay. Now, e power x minus 1 will cancel this 1 out. Okay. You can see that clearly, right? People, are you listening?
Yes, sir.
Yes, sir.
Do you want a minute break or something? Like to wash your face and come back?
No, sir. It's fine.
No,
You
sir.
feel it's useful, I'll give it to you right now. That's why. Like, I want the class to go smoothly. That's my final objective here. Okay. So for that, I need your support as well. All right. So here, 1 and minus 1 cancels out. X is there. The x in the denominator cancels out. There is x in every term in the numerator. Okay. So then, what happens here? This becomes 1. This becomes x by 2 factorial. Become x square by 3 factorial. And so on. And you're putting limit x tends to 0 here. What makes that everything else becomes 0 except this one? Or just remember, limit e power x minus 1 by x is 1. All right. E power x minus 1. The numerator, if you differentiate, you get e power x. Denominator, if you differentiate, you get 1. You put limit x tends to 0 here, you get e power 0, which is 1 by 1. That is also 1. This is L'Hopital rule. Okay, don't forget. I can't believe I'm using L'Hopital rule to explain to you guys. But anyway. Oh yeah, try this problem. Right. E power sin x minus 1 divided by tan x. Okay, what does this become? Come on, quickly. This formula is very important, okay? E power x minus 1 by x. And stress on the importance, but it's very important, very useful as well. So,
Minus
yeah,
1, sir.
exactly. So what do you do here? You wrote tan x as sin x divided
By
by
cos x.
cos x. So I like cos x separately here for demonstration purposes. So this becomes e power x minus 1 by x, where x tends to 0. You see, sin pi is 0. That's right. Okay. E power x minus 1 by, yeah. Doubt? Any doubt? All right. I'll continue, but if you have a doubt, please ask again. Okay. So then this turns out to 1, and this turns out to cos of pi when you put x tends to pi here. All right. So e power 0 minus 1 divided by 0 is what is basically happening. E power x minus 1 divided by x, where x tends to 0. So x is sin x. You don't worry about this part here, the angle part. No, no, no. That e power, whatever it is what you're worried about. Okay. Is that going to 0? That whatever part. Right. So cos pi is nothing but minus 1. So 1 into minus 1 is nothing but minus 1. That will be your answer. Okay. So this limit x to b e power x minus e cube divided by x square minus 9. Okay, guys, quickly, come on. Okay, I'll start the problem. Not responding. E cube into e power x minus 3 minus 1 divided by x square minus 9 is what we have. So let that x minus 3 into x plus 3 and limit. Oh, I'll keep forgetting this. X tends to 3 here. All right. So, what is this part here? I'll just shade it out. What is this part here?
1.
Limit x tends to 3 means e power 0 minus 1 divided by 0. Something e power x minus 1 divided by x, where x tends to 0. That is a form I got this into. Okay, so this whole thing becomes 1, and then I'm left with cube by my answer. Any doubts here? Any doubts here?
No, sir.
No, sir.
All right,
No, sir.
so we'll be moving ahead with few more formulas here. The second one would be limit x tends to 0, a power x minus 1 divided by x. What will this come out to? The a is a permissible value. Okay. A is greater than 0. It's a constant. A is not equal to 1. Okay, a is a permissible value. What will happen to this? A power x minus 1 divided by x. So this becomes ln a.
Log A.
Yeah, exactly. Natural log. We put log to the base e. Right. So I'm just writing it specifically as ln a. Now, a power x, if you differentiate, what do you get? ln A
A
into A power x,
log.
right? And denominator will become x. Sorry, denominator becomes 1. When you put x into 0, A power x becomes 1, and you're left with ln A. That's the rule explanation. Generally, what you do is you expand it and then deal with it, but that is not required right now. Okay, so let's move ahead to the next formula. So we get limit x tends to 0. I want you guys to be very familiar with all these formulas. Okay, they're very important from the JEE perspective. This also comes out to 1. Okay, sorry, ln of 1 plus x divided by x comes out to 1 here. Okay, just remember this part. Because when you differentiate ln of 1 plus x, what do you get? 1 by 1 plus x. And then denominator becomes 1 here. All right. So then when you put x into 0, x becomes 0, you get 1 remaining here. All right. 1 is all that remains. Now, next part says, okay, slight twist. Log 1 plus x to the base a. What does that become? Guys, come on, what does this become? Log to the base anything can be written as log 1 plus x to another base divided by log a to the base e, right? And this part you already know. This comes out to 1 when you put limit x tends to 0. This part I keep forgetting. All right, so this comes out to 1, and then I get 1 by ln a. All right, so this formula also remember. Like basically just remember one of these, but know how to transform either of these. Okay. All right. Now,
So
give
one
you some.
second, could you scroll up 1 minute?
Yes. So to the second one.
No, sir, I copied. It's fine. I just missed one part of it. I got it.
Okay. Guys, I'm not even noticing whether I'm scrolling down fast. Okay. So please respond like this. All right. Then I'll understand how much I'm going too fast, if I'm going too slow, all of it. Let's start questions. Okay. Try this question out, please. Okay. What did you do here? Ln of cos x will be the biggest confusion there. Okay. So you
Sir,
know, yeah, tell me.
so can we write
Yes,
it as, can we divide and multiply the numerator by cos x minus 1?
Hmm, you have to do that. You'll have to do that. I agree. I agree. All right. So then it becomes cos x minus 1 into cos x minus 1 and cos x minus 1. That's what he meant, right? Not cos of x minus 1.
Yes, sir.
Then the sin x, sin 3x and sin inverse 2x. This is nothing but distraction. You can easily solve this. Okay. Now, the numerator there was cos x. So I write that as 1 plus cos x minus 1. And I see that as x tends to 0, this part also tends to 0. Like as in if I put t equal to cos x minus 1. Okay. As x tends to 0, what happens to t? T tends to 1 minus 1, which is 0, right? Okay. So this becomes ln of 1 plus t divided by t form. Okay. This part here becomes ln of 1 plus t divided by t. Okay, where t tends to 0. And that blue part comes out to nothing but 1 here. Okay, what is remaining here? Cos x minus 1 divided by sin 3x and sin inverse 2x. Will you get scared by seeing all this? No, right?
No, sir.
Why? What happens here? You have sin 3x here. You divide it by 3x. You have sin inverse 2x. Let's divide that by 2x. We already have that x is tending towards 0. All right. Got this? So sin inverse 2x, you divide that by 2x. Now this 3x and 2x, we pull it out of thin air. So to compensate for that, we multiply by 6x square here. All right. And I can see that this part and this part is nothing but 1. And then I have cos x minus 1 divided by 6x square. I'll write that as 1 by 6 into cos x minus 1 divided by x square. Right? What does cos x minus 1 divided by x square come out to? Does that look familiar to you? When you put x equal to 0, what does cos x minus 1 divided by x square come out to?
0 by 0.
It's 0 by 0, but there's a formula I gave you in the beginning. Do you remember that? Like 1 minus cos x divided by x square.
Yes, sir.
Okay. So you
Minus
bring
2
that
signs.
exactly. No. 1 minus cos x divided by x square. We got it as 1 by 2. Do you remember? Like check the initial problems you said. Check the initial ones today. Like after sin x by x, after I taught you sin x by x,
Yes, sir.
there's 1 minus cos x by x square, right? That came out to 1 by 2. Directly apply Lapita if you want, okay? Right. So from here you get the answer as minus 1 by 12. Right. Okay. Okay, so cos x minus 1 by x square should come out to minus 1 by 2. All right. So this whole thing comes out to minus 1 by 12. Guys, any doubts? Any doubts here? Like calmly sit and solve it on your own. Like figure it out. Like the nuances. There's a minus 1 there, there's a 1 there. Look at the denominator. How does that change? Like, there are so many parts to this problem, okay? Like, but I'm pretty sure that by now that sin 3x and sin inverse 2x will not scare you henceforth in the denominator. Like whatever comes, yeah, that should not scare you. We'll try a similar problem quickly. Where minus Okay, what happens here?
So, sir, 0 by 0.
Yeah, it will be 0 by 0 form. Yes, yes, yes. Because when you put x tends to e, numerator becomes 1 minus 1, 0. Denominator also becomes 0. Here, how do we proceed? Without using Lapita, without using Lapita. Okay. We have sin x minus 1 divided by x square minus e square. Guys, just give me a second. Hello. Yeah, it corrected it. Yeah, thank you. Yeah, thank you, thank you, thank you. Yeah. So, what's the answer you're getting here? Or are you getting any answer here? Simply write 1 as ln of e. Okay. Hope you'll get where I'm going with this. Becomes limit x tends to e. Ln of x by e minus 1. Divided by square minus e square, I'll either x plus e into x minus e. X plus e, you know, comes out to 1 by 2e. So I'll just take it out here. And then there is an x minus e remaining. All right. We are still sorry. This minus 1 won't be there anymore. Right? Minus 1 will vanish. Ln a minus ln b is ln of a by b. Then I get 1 by 2e into limit x tends to e. Ln of, what will I do here? Once I see ln, I'll try to bring it into that 1 plus x form. So for that, 1 plus by e minus 1 form. Okay, divided by x minus e I have. Right. So I'll simply take e out from this and then I get x by e minus 1. So now, when x tends to e, I can see that x by e minus 1 is tending towards 0. Okay. This is my x part. When I talk about ln of 1 plus x divided by x. All right. So this is the x part. This is tending to 0. Sorry, x by e minus 1 is tending to 0. All right. So this becomes ln of 1 plus x divided by x, where x tends to 0 that way. Then I get my answer as 1 by 2e square into, what is this? Ln of 1 plus x divided by x. Nothing but 1. Okay, so I get my answer as 1 by 2e square. Are you following?
Yes.
Right. So let's just move ahead. If you didn't follow that, please just look at the video again. You will figure it out. It's not that hard. Now, last practice question for the day will be, no, we'll practice much more. e power tan x minus e power sin x divided by e power 2x minus 1 into tan inverse 2x into sin 3x. Okay. I'm leaving this to you. Come on, start doing this. The tan inverse 2x sin 3x and all, you can deal with it in one go. Don't focus on that. Look at the denominator. Look at the numerator. All right. E power tan x minus e power sin x. So here, my first step would generally be, I'll just start the problem off for you. I'll take e power sin x common. So then I'm left with e power tan x minus sin x divided by e power 2x minus 1. 2x minus 1. Tan inverse 2x sin of 3x when x tends to 0. Okay, what do you do here? Guys, can you please respond or are you trying the problem?
1 minute, sir. But do we divide sin 3x by 3x in the denominator?
That will happen anyway. That's the fact. Okay. You'll divide sin 3x by 3x. You'll divide tan inverse 2x by 2x as well. And you'll make up for that by multiplying by 6x square as well. All of them will cut out to become 1. That is fine. But the important part is not there, right? The tricky part is somewhere else. You understood it's a distraction. That's a good part of it. Okay. That tan inverse 2x sin 3x is nothing but distraction. You can quickly solve it. The remaining part, how do we deal with it? So that you use e power x minus 1 divided by x equal to 1 when x tends to 0. So here, in our context, we have, what do we have? We have tan x minus sin x here. We have 2x here. When x tends to 0, both become 0. So we should multiply and divide by that value itself. Okay, getting it? Thing is, when I look at this, what do I see when x tends to 0? The numerator becomes 0. Denominator becomes 0 3 times. All right. So you are looking at 0 by 0. And how do we deal with it? For that, okay, sin 3x, I'll simply divide by 3x and I'll simply divide by 2x. Okay, that's the first part all of us know. So we'll multiply by 6x squared. All right. Then what do we have? We have tan x minus sin x here. If I multiply and divide by tan x minus sin x. Okay, what will happen? This divided by this becomes, okay, this part divided by this part. Okay, what does that become? It becomes 1. E power x minus 1 divided by x when x tends to 0 is 1. And here instead of x, you have tan x minus sin x. Okay, all right. Similarly, here what do? You'll divide by 2x. E power x minus 1 divided by x. So to make up for that, you'll multiply this by 2x as well. Okay. Are you following what happened here?
Yes, sir. Yes, sir.
Okay, so when you put limit x tends to 0, you have e power sin x into 1, which is this part, into tan x minus sin x divided by this part becomes 1. This part becomes 1 into 12 x cubed. So x tends to 0, e power sin x becomes 1 as well. All right. E power 0 is 1. So I'm just left with tan x minus sin x divided by 12 x cubed. Guys, did you get till here?
Yes, sir.
Understood.
Okay, good. Now, can you solve it from here? Please try. Please try. What happens when you solve this from here? I'll take sin x common. This becomes 1 by cos x minus 1. Okay. So 1 by cos x minus 1 can be written 1 minus cos x by cos x into x cubed. Limit x tends to 0. For thinking here is, when I put limit x tends to 0, cos x becomes 1 here. Right, so that goes off as 1. I have sin x. So x cube I write it as x into x square here. Right. So sin x divided by x and 1 minus cos x divided by x square. What is 1 minus cos x divided by x square? Limit x tends to 0. That's 1 by 2. Sin x by x is 1. And then you have 1 by 12, which is already there. So this comes out to nothing but 1 by 24. Got this?
Yes, sir. I got it. After you solved it.
That's okay. That's okay. The point is, okay, guys, take 2 minutes out and look at the problem again. And try to solve it again on your own without looking at the problem. Actually, yeah, don't take 2 minutes out to look at the problem. Try to solve this problem again without looking at the solution. Okay. All right. Please try. Please try. I want your understanding to be perfect now. Okay. You're getting into the groove of limits. There's only one more form left, 1 power infinity. Rest all other forms we've completed. You didn't realize. Right? This is the fastest I've taught the chapter limits. So I want your practice to be solid so that our communication is good here. So please try this problem again right now. You know the solution, you've seen it once. Doesn't mean you know it. Okay, you've seen it once. Apply and try to get to the bottom. Come on. It'll hardly take 2 minutes now. That's it. Explanation took 10 minutes, but yeah.
solved it, sir.
Hmm?
I solved it.
Is there any doubts here?
No, sir.
So this problem is done.
Yes, sir.
Okay. So then the class is done for today. Thank you for joining, guys. Great.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. Thank you. Take care.
Thank you,
Yeah.
sir. You too.
All right.